The last chi-square test that we're going to review is the chi-square test of independence. The chi-square test of independence is calculated a little bit differently than the previous two examples of chi-square tests, and we're going to go over that right now. First of all, one of the most important things is you have to be very familiar with the chi-square contingency table, what's called a contingency table. We're doing a chi-square 2 by 2. And what that means is we have two variables, each with two levels. One variable is sex of the subject that's being queried. The subject is either male or female. And the second variable is reports texts while driving, no and yes. So you have a sample of 120 undergraduates who you've polled, and you've determined for each subject who participates in your study of the 120, you ask them to check off whether or not they're male or female, and then you ask them to whether or not they text while driving, and it's a simple yes/no question. So it's a very little poll that you're doing with your 120 subjects. You just want to get an idea of whether or not there may be a difference between males and females with regard to tendency to text while driving. So what you see here are the numbers of subjects, the numbers of observations for each of these mutually exclusive categories. Now, when I say mutually exclusive, I mean that a person, a subject in your study, can be categorized in one and only one of these cells. There's no overlap. So in other words, a person either reports themselves to be male or female, and they report that they either text while driving or they never text while driving. All right? So that means you can't have one person who is accounted for in more than one cell. Now, what does this table show us? Let's start with the four inner squares. These are your frequencies observed, right? In your sample of 120, these numbers indicate that of the males that you polled, 48 said that they never text while driving, and 22 said that they do text while driving. And you had a total of 70 males in your sample of 122. With regard to females, you had a total of 50 females out of 120 subjects, 19 of whom reported that they never text while driving, 31 of whom say that they do text while driving. Now let's look at these other values. This is your row total. The row total, this is the total number of subjects who reported that they never text while driving, regardless of sex. So out of your 120 subjects, 67 said that they never text while driving. It happens that 48 of those were males and 19 were females. This row shows you the total number of your subjects that say that yes, they do text while driving. So out of your 120 subjects, 53 report that yes, in fact, they do text while driving. 22 of them were males and 31 of them were females. All right? So these are your observed frequencies, and you get your outer totals by simply adding together the numbers in the row and in the columns. 19 plus 31 is 50, 48 plus 22 is 70, again 48 plus 19 is 67, and 22 plus 31 is 53. Now, how do you get your your expected frequency for each of these cells? Well, this is calculated by multiplying the column frequency times the row frequency and dividing by the n. And these formulas ran together a little bit, but this is let's draw a line here so it's very clear. Right, and this is n. This belongs down there. Okay, so let's do that now. And I'm not going to do all of these. I filled these in for you already. But I just want to demonstrate to you how we do this. Let's say we want to know what is the expected frequency for males who say they never text while driving. Well, if we take 67 times 70 and divide by 120, this total sample size, we get 39.08. 39.08 is the expected frequency for this cell. Let's do this one. If we've observed 31 females who say they text while driving. 31 females out of our 120 say that they text while driving. If we want to know the expected frequency for this cell, we take 53 times 50 and divide that by 120. and that gives you 22.08. That is your expected frequency for this cell. If we did the same, that's how we got these numbers, all right? So let's go on now and calculate our chi-square. Now the formula for our chi-square is the same as it was previously. It's simply the sum of the frequencies observed minus the frequency expected squared divided by the frequency expected, right? So that gets rid of the square. All right. So let's say for the first cell, and we have to do this for each of these cells, frequency observed, 48, minus frequency expected. And we square this, 8.92, and we divide that by the frequency expected, which is 39.08. And that gives us a value of 2.04. Okay, let's do our next cell. Moving across here, we do 19 minus 27.92. 8.92 times 8.92 equals 79.56 divided by the frequency expected. Do it again. Make sure I didn't hit the wrong button there. 7.92. That's right. By 27.92, and we get a value of 2.85. All right, let's do the next one down here. We have 22 minus 30.92 gives us 8.92. Right, do you see a pattern developing here? By, right, 2.57. What do you think the numerator of this one is going to be? 31 minus 8 times 8.92, 79 divided by 22.08. Here we get 3.60. Okay, now if we add up those numbers, we get 2.04 plus 2.85 plus 2.57 plus 3.60, 11.06. Okay, what was our chi-square critical value? 3.841. So now you're at the point where you have to evaluate this chi-square statistic. Ask yourself first whether or not it exceeds this, and if so, proceed to do the post hoc test.